Okay, let's paint a picture. A single misstep. You're at the edge of one of the deepest holes on Earth. What happens next? Well, today we're exploring the absolutely terrifying physics of what happens when you fall 3,000 meters straight down. Buckle up. So, just imagine it for a second. One wrong step, a moment of carelessness, and suddenly you're plummeting into what feels like a totally bottomless abyss. The real question is, what actually happens in those moments that follow? All right, first things first, we really need to wrap our heads around the sheer scale of this fall. I mean, 3,000 meters? That's a distance that's honestly hard to even imagine. So let's try to put it into perspective.
3,000 meters. That's 3 kilometers, straight down. It's a number so big it almost feels abstract, right? This isn't just a fall, it's a journey, a terrifying journey, deep into the earth itself.
And here's maybe the best way to think about it. Imagine falling past 9 Empire State Buildings all stacked on top of each other. That's the kind of distance we're talking about here. And you're covering all of it as you plunge deeper and deeper into complete darkness.
Okay, so as you're falling, you're picking up speed, like incredibly fast. But here's the thing, you don't just keep getting faster and faster forever. See, there's this fundamental law of physics that kicks in, and it's what dictates the absolute top speed of your descent.
And that law is all about something called terminal velocity. What is that? Well, it's basically the point where the pull of gravity trying to speed you up is perfectly matched by the push of air resistance slowing you down. The two forces cancel each other out. So you stop accelerating and you just keep falling at a constant and very, very fast maximum speed.
It's a pretty straightforward process when you break it down, right? First, gravity yanks you downward, making you go faster. But at the same time, air resistance is pushing up against you. The faster you go, the stronger that upward push becomes. Eventually, those two forces balance out perfectly, and bam, you've hit it. You've reached your max speed.
And what is that speed for a human body? Well, it's somewhere around 200 kilometers per hour. Think about that. That's the speed you're doing on a highway. But you're not safely inside a car. You are the projectile hurtling through the darkness. So you've hit your top speed, you're not getting any faster. But remember, you still have an incredible distance to go. This isn't like jumping off a diving board. It's a long, sustained plunge that would feel like an absolute eternity. So what would that even feel like? I mean, the wind wouldn't just be a breeze. It would be a deafening, constant roar in your ears. And after the first few seconds of light from the entrance disappears, you'd be in total pitch black darkness. The weirdest part, because your speed is constant, you'd feel almost weightless, like you're just floating. It's wild, but survivors of much shorter falls often say that time itself seems to stretch out and slow way, way down in these moments. This timeline really puts the whole terrifying journey into perspective. You hit that terminal velocity in just about 12 seconds, but the fall itself, that lasts for an unbelievable 2.5 minutes. Just try to imagine that. Almost 3 full minutes of falling at highway speed in complete and utter darkness. But after those 2.5 minutes, the journey is over. And now we have to face the brutal, unavoidable physics of what happens at the very end. You know, there's that old saying, it's not the fall that gets you, it's the sudden stop at the end. And that has never, ever been more true than right here. The fall itself, that feeling of weightlessness in the dark, that's not what's lethal. The real danger is the moment you go from 200 kilometers per hour to 0 in a fraction of a second. So is there any hope at all? I mean, even a tiny sliver? Well, the best case scenario is a 1 in a billion long shot. Somehow landing perfectly feet first in incredibly deep water or super soft porous mud that could cushion the impact. Even then, survival is almost impossible. But the much, much more likely reality, hitting hard rock or metal debris or even shallow water. And in that case, the impact is instantly and completely unsurvivable. Okay, so let's get to the core of it. We need to understand why this fall is so lethal. It all comes down to one final brutal concept in physics: deceleration. Simply put, our bodies, they just can't handle it. We are not built to withstand the massive, massive forces of stopping that quickly. We're talking about a force hundreds of times greater than gravity itself, causing catastrophic internal injuries that nobody could possibly survive. And this really just says it all, doesn't it? The forces at play are astronomical.
To survive a fall like this wouldn't just be lucky, it would be a 1 in a billion miracle of physics, where everything would have to go perfectly right, in the most impossible way. The science here is just too powerful. And too final.
And thinking about all this, it just leaves you with a bigger question, right? A 3,000-meter fall is pretty clearly beyond the limit, but it really makes you wonder, what is the absolute limit of human survivability? Where is that line?